another common class for this week. All we're working on the geometry with points and lines, and we talked about angles and this different line. As you tell by the title, we're going to think some of the things start putting into different. So we're going to talk about quadrilaterals, and we're going to talk about some others as well. The thing to notice on this quadrilateral little page here is that all these quadrilaterals have four bases, and then part D that have a plank up of what them need. For look at this page, I can set their word parallel in the word parallelogram. So a parallelogram sets of sides for an example. We'll get that as you go. So our quadrilaterals have four sides, angles. We have different types. So if we look at this little, we can see that parallelogram can also be parallelograms like a square can, and just like become of parallel side. If trapezoid is not considered a parallelogram, the trapezoid only has one set of parallel sides, and as you find line there. All right, so if we look at types of quadrilaterals, just another little way that it breaks it down. This might be a good place for you to pause the video if you want to kind of take a closer look at this chart. But the first thing I notice at the top, I see a quadrilateral. And remember, quad means four. So quadrilaterals has four sides and four angles. So if we start over here with a kite has two pairs of adjacent sides and two pairs of congruent sides. Congruent means the same size or the same length. So you can see that they have two sets of sides that are the same length, and adjacent just means that they are across from each other. When we go to the middle, quadrilaterals with one set of parallel sides, that's where we start talking about our trapezoids. So you can see this trapezoid has a parallel line here and this one, but this kind of top diagonal line and the bottom line would not be parallel because they're eventually going to cross down here somewhere. And then an isosceles trapezoid, you can see that it also has just the one set of parallel lines. If we move over to two pairs of parallel lines, that's where we get into our more common quadrilaterals. There's our parallelogram again, two sets of parallel sides. And then if we move down to four equal sides or four congruent sides, we have a rhombus. Kind of looks like a diamond. And then we have parallelograms that have four right angles. That's where we move to our rectangles and our squares. So this is just kind of a good little visual chart to kind of see how we classify our quadrilaterals. So probably one of the most recognizable quadrilaterals we have is a rectangle. So when we go through each of these shapes, we're going to talk about not only the sides and the types of lines they have, but we're also going to talk about angles. I know Mrs. Johnson went over some angles with you last week. So a rectangle is a quadrilateral, four sides, right? With two pairs of equal sides and four right angles. So if we just talk about the sides, we can see this top side and this bottom side are equal, as it indicates with kind of just the one dash or the one line. And then when we have two lines, the shorter sides, those two would be equal as well. So that's the length of our sides. Now if we talk about the lines, our top line and our bottom line are parallel with each other, and our two side lines are parallel with each other as well. When we think about lines being perpendicular, remember, if we have this top line and this side line, if we continued them on, they would kind of form that intersection. And because we know that this is a 90-degree angle or a right angle, we would say that those lines are perpendicular. So with a rectangle, we have two sets of parallel lines, perpendicular lines, and they form four 90-degree angles. All right, so moving on to our parallelogram. Remember, in the word parallelogram, parallel, which means a quadrilateral where opposite sides are parallel and an equal length, and opposite angles are equal. So let's talk about the sides first. Top line and bottom line would be parallel, and they're the same length. And sideline and sideline would be parallel, and they're the same length. When we talk about angles, we took that rectangle and just kind of pushed it over, pushed it to the side. We have an acute angle down here, less than 90 degrees, an acute angle up here, less than 90 degrees, and then our other two angles would be obtuse, which means they are greater than 90 degrees. Moving on, probably the most famous quadrilateral, we have a square. Similar to a rectangle, very similar. Quadrilateral with 4 equal sides and 4 right angles. So if you remember a rectangle has 2 sets of equal sides. A square has all 4 that would be equal. And again, they're forming those perpendicular lines because top line and side line, when they intersect or when they cross, they form that 90-degree angle. So again, 4 90-degree angles on our square. And of course, 4 equal sides. All right, a rhombus. Similar to what we did with a parallelogram, we're going to take that square and we're just going to kind of push it over. So a parallelogram with 4 equal sides and opposite angles are equal. So very similar to the definition of a parallelogram. The only thing that's different is we would have 4 equal sides instead of 2 sets of equal sides. Still 2 acute angles. Here would be an acute angle, and here would be an acute angle, and here would be obtuse and obtuse. All right, let's talk about trapezoids. So a trapezoid is a quadrilateral. Quad means 4, so quadrilateral with 1 pair of parallel sides. So the top line and the bottom line would be parallel. If they were to continue on forever in both directions, they would never cross. Similar to last week when we talked about railroad tracks or the lines on the highway, they can follow a curve, but they're never going to cross. You can see the 2 sides. If we were to extend them way up here to the top of the page, right about up here is where they would cross or they would intersect. So we wouldn't consider those parallel. And one thing I added down here, this is kind of a trapezoid that we're not usually used to seeing. This is more of the trapezoid down here that we're used to seeing. So you can see top line and bottom line again are parallel, and then those 2 sides are eventually going to cross if they were to extend up top. So that's kind of the definition of a trapezoid. All right, let's talk about irregular shapes. One way to think about the word irregular, it means odd, it means different, it means kind of strange. So irregular shapes are quadrilaterals with no equal sides and no equal angles. So if you look at this quadrilateral, we can see that all 4 of the angles are different sized and all 4 of the sides are different lengths. So it's still a quadrilateral because it has 4 sides and 4 angles, but it is called irregular because they are all different. All right, so let's talk about the angles, interior angles. So last week when Mrs. Johnson talked with you about angles, she talked about obtuse, acute, and right angles. But now when we think about a quadrilateral, we said a quadrilateral has 4 different angles. So an interior angle is an angle formed by 2 sides of a simple polygon that share an endpoint. So that would just mean like each corner would be an endpoint, and each corner where 2 lines come together, that's where it would form one of those interior angles. If it's a quadrilateral, we know that there has to be 4 interior angles because 4 sides and 4 angles. And the cool thing about this, the sum of interior angles of a quadrilateral is always equal to 360 degrees. So if you think about a circle, how a circle is 360 degrees, in order for it to be a quadrilateral, all 4 of those sides eventually have to connect, and they would add to 360 degrees. So let's kind of look at it to make it a little bit easier. So here, this first example, I have a trapezoid. You can see that I have 4 points or 4 vertices, A, B, C, and D, and each of those points where the 2 lines come together, it forms an angle. So Angle A is 45 degrees, angle B is 135 degrees, angle C is 120, and angle D is 60. So I see two acute angles, A and D, and I see two obtuse angles, B and C. So looking over here at my math, I took my 135-degree angle, angle B, added 120, angle C, added 45, angle A, and added 60 degrees, angle D. So when I add 135 degrees plus 120 degrees plus 45 degrees plus 60 degrees, it adds up to 360 degrees, or it forms that kind of circular pattern, or it completes the circle of 360 degrees. On my second example, same thing, but now I have a square. I still have my four angles. They're not labeled, but we can see one in each corner, and these little boxes represent 90 degrees. So we know in a square that it forms four 90-degree angles. Here's my four 90 degrees over there. 90 plus 90 plus 90 plus 90 equals 360. So think about those interior angles. All right, let's talk about some other shapes that you might see. So in a right triangle has one right angle and two acute angles. So if we look down here, here's my 90-degree angle, or my right angle, and then each of these other two angles are going to be less than 90 degrees. A right triangle has one set of perpendicular lines. So here's my set of perpendicular lines. Here and here, and where they cross down here at that 90-degree angle makes them perpendicular. It also would then have a set of intersecting lines here and a set of intersecting lines here. Another way to see it, AC intersects with CB, and it forms that 90-degree angle, so it would make that a right triangle. Hexagons. Hexagons are one of my favorite shapes. Hexagons are six-sided polygons. Hexagons have six obtuse angles. Hexagons have three sets of parallel sides with no perpendicular lines. So here's my first hexagon, labeled all those 6 points, A, B, C, D, E, and F. And then each one of my angles would be 120 degrees. So it would be obtuse angles. They would all be the same, especially on a regular hexagon. Now, if we start getting into irregular hexagons, the definition changes, but these are regular hexagons. And then this last diagram really talks about the three sets of parallel sides. So you can see letter B and letter B, this line and this line would continue on and be parallel. Line A and line A would be parallel, and then line C and line C would be parallel. And you can see where those lines intersect, like A and B, it wouldn't form that 90-degree angle, so we would just say those are intersecting lines. This might be a great place to pause the video and really check out that third diagram so you can see how those lines are parallel. All right, tomorrow's scavenger hunt. Tomorrow for your assignment, we're going to do something a little different, a little fun. We're going to have a little kind of cheat sheet for you, and we want you to just get outside, and you're going to be looking for some real-world examples of types of lines, types of angles, different things that you can find out in the real world. So if you look at my three examples, of course I had to include a baseball diamond. You can see different angles being created. You can see different shapes being created, maybe the way the grass is cut, maybe in the bleachers. You can see different types of geometrical figures. Second one, we have this fence. I see some parallel lines, but I also see some perpendicular lines. Same thing with the bricks. I can see parallel, but I can also see perpendicular. Tomorrow's assignment will explain the scavenger hunt a little bit better for you, but go back and use this video, use the slides to kind of help you get a better understanding of how angles and lines are found and used in shapes. Let us know if you have any questions.